very glad to be with you here for this video number 2 of the Pulp and Fuel project. My name is Jeremy Boucher. I am in charge of the Research and Development Department of Fibre Excellence. Fibre Excellence is a French company. It operates 2 mills in France to produce pulp from wood. As you can see, we consume more than 2.2 million tons of wood per year to produce pulp. And Fibre Excellence is also a producer of green electricity. One part of my job is to, as a researcher, is to find new application from wood by using molecules lost in the process, such as hemicelluloses, or also some part of wood that we can also already use to produce energy, for example, lignin, for example, bark, and maybe to find a better application, which is the purpose of this project. In this project, Fibre Excellence is at the very beginning. We are, of course, expert of the pulp production process. We can provide some data for the modeling of the process, for example, and we are also providers of raw material such as bark and black liquor. But I am here to explain you the context of this project and why we had this smart idea to see if we can produce pulp but also fuel in this kind of company. To understand that, I have to explain you how we produce pulp nowadays in the pulp mills. So maybe you know that everything starts with a log. Here, wood logs. These wood logs are the bark. We obtain bark, and this bark is burnt in a biomass boiler to produce steam and then electricity. And the wood is cut to obtain chips. These wood chips are made of 3 main components: cellulose, hemicelluloses, and lignin. And to simplify, cellulose and hemicelluloses are the main component of fibers, the wood fibers, but also the fiber to find in the paper. Whereas in wood, lignin can be seen as a kind of matrix surrounding the fibers. Fibre Excellence uses the craft process. This is the process used to produce more than 75% of pulp in the world. And this is a chemical process. In this process, we will isolate the fibers by depolymerize, solubilize, and extract the lignin. As we extract this part of wood, there is this kind of yield of production. For example, with 100 kilograms of dry chips, we obtain 40 to 50 kilograms of pulp. As I said, this is a chemical process, so we need chemicals. The chemical used in the crush process are soda and sodium sulfide, Na2S. And the solution containing these chemicals is white. That's why we call that white liquor. The white liquor and the wood chips are mixed together, and a craft cooking is performed at high pressure, high temperature during a few hours. At the end of this cooking, we separate the liquid part to the solid part. The solid part is the fibers. They are bone. You can have bone pulp and bone paper at the end, a craft paper, but you can also bleach this pulp if you need to have a white paper at the end. But this is not the purpose of this presentation. Here we will be focused on the chemicals and the liquid part. So as I said, after the craft cooking, you separate the solid part to the liquid part. The liquid part is made of spent chemicals obtained after the cooking, and also all the organic matter solubilized during the craft cooking, and especially the lignin. Lignin is black, the liquid obtained is black, that's why we call that the black liquor. In the traditional craft process, this black liquor is concentrated by evaporation and burned into a recovery boiler, specific boiler. And in this boiler, after the combustion, you obtain steam, and you can have electricity from this steam. But there is also some chemical reaction in this boiler, and the sodium sulfide is recovered in this boiler. So if you remember, in the white liquor at the beginning, there was soda and sodium sulfide. So we recover one of the 2 main components of the white liquor. This component is obtained in a smelt. This smelt is put in a liquid. We obtain a green liquid. We call that green liquor. and this green liquor containing sodium sulfide, but also sodium carbonate. And if we want to recover the white liquor, we need to obtain soda from this green liquor. And for that, we will put lime in the green liquor. And this lime will react with sodium carbonate to obtain soda and calcium carbonate. As you know, maybe calcium carbonate is not soluble in water, so you can remove it from the liquid part by something like a filtration. And after this operation, the liquid obtained contains soda and sodium sulfide, and this is the white liquor. You recover it and you can use it to operate another craft cooking. But this is not finished, because you can also recover the lime if you burn the calcium carbonate into a lime kiln. And with the two recycle ways, you recover more than 99% of the chemicals used in a craft cooking. So to conclude, as I said, you recover the chemicals by burning the lignin, but also if you burn bark and lignin, you produce steam and electricity, and you have more energy than required for the process. So you can sell, for example, green electricity. This process produces extra energy. But bark and lignin are burnt, and we think that even if it's interesting, of course, maybe it's not the best application you can have from these components. We think that maybe better solution can exist, and one of these solutions can be fuel production with some gasification. To produce fuel, we imagine a process. I will explain it now. In this process, the black liquor is not burnt into a recovery boiler, but this liquor is gasified. This is a specific gasification, a supercritical water gasification made at high pressure and high temperature. And after this gasification, we obtain from the organic matter, we obtain a syngas rich in hydrogen. But that's not all. Bark will also add a gasification. This is a dry gasification, traditional dry gasification. And after this gasification, we will obtain some carbon monoxide. Carbon monoxide and hydrogen will be mixed together and clean because it can contain some sulfur, for example. And if we obtain a good ratio between these two components, we can perform a Fischer-Tropsch reaction, and at the end of this reaction, obtain some fuel. So you can see here how we can produce pulp and fuels in the pulp mill. Here, it's not all, just a small point. We think that it's possible, also after the supercritical water gasification, to obtain different products from the lignin, for example, polyphenols. And another partner, Grenoble INP Pagora, work on this part and see by adjusting the setting of this gasification, see what kind of product we can obtain and if we can find application from these products. So to conclude on this presentation, we have seen that in the craft pulp mill, energy is produced from combustion of bark and lignin, more energy than required in the process. Almost all chemicals are recovered during the combustion of black liquor. But we think that instead of burning this component, we can obtain different value-added products with a higher value. And we think about producing fuel by gasification of black liquor and bark. So I thank you all to stay here with me. Let's see the other videos of this project, and you will see in detail the process I described here for you. Thank you very much.